Hey y'all, this is Miss Marty. How are you today? Okay, so today we're going to recap what we talked about last week, and that is graphing rational functions. One of your definitions is an X-intercept, and this is true for all functions. An X-intercept occurs when y equals 0 and the graph crosses the x-axis. So in the case of the function f of x equals x plus 3 divided by x minus 1, that's actually the same as saying y equals x plus 3 over x minus 1. So somewhere in the back of your mind, you should always remember that f of x and y mean the same thing. So we're going to look at where y equals 0, and when y equals 0, we can solve for x. And it's asynchronous time, by the way. When x equals 0, when y equals 0, sorry, I'm going to multiply both sides times x minus 1. And then these two stinkers cancel. And anything times 0 is 0. So x equals negative 3. For those of you that can't see that, feel like I jumped a step, I just subtracted 3 from both sides. So that's all there is to that for your X-intercept. An important note here, f of x is simply a super convenient notation. So in this case, we can say, in this example, we can say that f of negative 3 equals 0. That is not important to the definition of X-intercept. I'm just going over this f of x f of x stuff. It's a convenient notation for y. So this is telling you that when x equals negative 3, because we replaced x with negative 3, then y equals 0. That's what that notation really means. Okay, so now we're going to go on and we're going to talk about the Y-intercept. So if an X-intercept occurs when y equals 0, then a Y-intercept occurs when x equals 0 and the graph crosses the y-axis. So we're going to use the same example here, and we're going to get a nasty number. But you're going to see that you can work with that nasty number. And all we need to do here is replace x with 0, so we're going to replace x with 0. See, there's a nasty number there, but when we simplify, we get 3 divided by negative 1, which is negative 3. And once we have that, we know that when x is 0, y is negative 3, because right over here, we said that when f of x is 0, y is negative 3, because f of x equals y. Now, we're going to go ahead and graph this function. And you definitely want to use Desmos to some degree, because we're not quite ready to talk about much more than what we've just done, unless you really process what we learned last week really well. And let me see here just a second. Okay. From Desmos, I can see that I have a graph that looks something like this. Actually, from my own brain, but you're using Desmos, So we have X-intercept, we have Y-intercept. Now we need to talk about our vertical asymptote, which is the next easiest thing involved here. A vertical asymptote occurs when the denominator equals 0. So we're going to still use that same function, and because we already have the graph up there, and that's going to become super convenient in a second. So we're going to set the denominator only equal to 0, and the denominator is the bottom of your fraction. So we have this vertical asymptote of x equals 1. And if you remember one of the most forgettable pieces of Algebra 1, honestly, nobody remembers this, so don't feel too bad. A line with an equation of x equals is always vertical. So your x equals 1 line goes up and down like this. And this is not actually part of your graph. This line, this pink line that I'm drawing, that is actually a line that the graph never ever touches. So that's why we make it dotted. And I tried to make it super light so that it was obvious that it wasn't part of the graph. Okay, that's how you find a vertical asymptote. A vertical asymptote occurs when the denominator equals 0. Moving onwards and upwards, we're going to go to a horizontal asymptote. So in this particular example that we've been working with the whole time, we look at this and we see that the degrees of our denominator and our numerator are the same. So all we need to do, well, low over high, no, that's not true because the degree in the top is not lower than the degree in the bottom. High over low, that's not true because the degree in the numerator is not higher than the degree in the denominator, but they both have the same degree. They both of these x's over here are to the power of 1. We could just write a little 1 in there and it would mean the same thing. Well, what does that mean? That means that our horizontal asymptote in our example is y equals 1. Same over same, coefficients you name. The coefficients here are 1 and 1. 1 divided by 1 is 1. So what does that mean for our graph? Our horizontal asymptote is also 1. Now we're going to go into this some more on the next slide with some more examples for you. But that is how much information you can get from just those little bitty pieces. And I didn't even need to look at the table on Desmos. So we look at this one and we need to find, first of all, our X-intercept. Our X-intercept or intercepts occur when y equals 0. So we set this equal to y equals 0, or f of x equal to y equals 0, which will mean that the top, only the top, will equal 0. Because when the bottom equals 0, we're talking about vertical asymptotes, because you can never divide by 0. So we look at 0 equals x plus 5 times x minus 1. Well, what times what is 0? The only thing that could possibly make this 0 is 0. So either this piece equals 0 or this piece equals 0. So when x plus 5 equals 0, x equals negative 5. When x minus 1 equals 0, x equals 1. So we have two x-intercepts there. We found our x-intercept. Well, I better label that for you. Now we're going to look at our y-intercepts. And our y-intercepts occur when x equals 0. So now we're going to write y equals 0 plus 5 times 0 minus 1, all over 0 plus 1, which is 5 times -1 divided by 1, which is -5. So our y-intercept is 0, -5. Okay, our y-intercept, our x-intercept. Now let's look at our vertical asymptote. Our vertical asymptote occurs when the denominator equals 0. And this is all very new. This is x-intercept and y-intercept you've done with lines and with parabolas. Here we solve and we get x equals -1. So that's where one of our dotted lines is going to be. Now let's think about our horizontal asymptote. Our horizontal asymptote occurs when we use that rhyme. Low over high is y. High over low is no. Same over same, coefficients you name. Well, in this case, you have to be really careful. And you have to really pay attention here, because when you look at this, you've actually got a x squared in the top, because when you FOIL first times first, you're going to get an x squared. So it's not same over same, it is high over low, which means there's no horizontal asymptote, which in fact means that there's a slant asymptote. So we're going to need to divide. So in order to divide, we first need to FOIL that stinker out. So x plus 5 times x minus 1. First times first gives us x squared. Outside times outside gives us -x. Inside times inside gives us 5x. Last times last gives us -5. And that was all over x plus 1. When we go to simplify that, we get x squared plus 4x minus 5 all over x plus 1. Now we finally get to the point where we can divide. And we're going to take x squared plus 4x minus 5 and divide it by x plus 1. What times x gives us x squared? X times x gives us x squared. We've only multiplied this times that. Now we need to multiply this times that. Oh, that's really messy looking, so I'm going to erase it. And x times 1 just gives us x. Now we're going to subtract like we did when we were in 5th grade and we were doing long division, because that's all this is. 4x minus x gives us 3x minus 5. What times x? What times x gives us 3x? 3. 3 times x gives us 3x. And again, we only did part of it. 3 times x gives us 3x. 3 times 1 gives us 3. So we put that 3 under there. And we've got a big fat minus, just like we did when we were doing long division in 5th grade. -5 minus 3 is -8. We can't go any farther. Our entire slant asymptote is x plus 3. Now we're going to graph this little stinker. We have a vertical asymptote at -1. We have a slant asymptote at x plus 3, y-intercept of 3. Oh, I can't get it to draw. Slope of 1, up 1 over 1, up 1 over 1, dun 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 dun. There's our graph, and that's not really our graph, that's just the asymptotes. And our x-intercepts are -5, 1, 2, 3, 4, 5. and positive 1. Negative 5 and positive 1. Okay. Then we don't need any more information. All we need to know is that our graph is going to hug our asymptotes. So we're going to take our line, our curve, and we are going to hug the asymptotes. And hug the asymptotes. This one's having trouble hugging. There we go. And there we go. That's what it looks like when you've got a slant asymptote. I'm going to move on to another example. Okay, we're going to look at our X-intercepts, our Y-intercepts, and then we're going to work with our horizontal or slant asymptotes. Now, if we look here, I'm going to start with X-intercepts. I tried to do the hardest thing first. That would have thrown you off. X-intercepts occur when y equals 0. So we set y equal to 0, and we're going to solve for x. And I'm going to keep it in factored form. This is one of the reasons I really like factoring, because it makes it so much easier to figure out what's going on. Now stop. I want you to notice something. If you look here, you have two factors that cancel out. That right there is dun, 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 a hole. That is not going to be an X-intercept, a Y-intercept, or an asymptote. A hole occurs when the top and bottom, the numerator and the denominator cancel. But we're going to talk about that later, because again, I'm still on the part where we're trying to set y equal to 0. We have to factor out that hole because it's meaningless. That's why I had to bring it up. Your graph is never going to touch that point. So 0 equals 2x minus 3. Add 3 to both sides. We get 3 equals 2x. Divide both sides by 2. And we get 3/2 equal to x. If 3/2 equals x, and we look at this, we know that we have an x-intercept at 3/2, 0. So we have 1 point on our graph already. Now let's see what happens when we look for our y-intercept. That occurs when x equals 0. So I'm going to replace every single x with 0. So 2 times 0 minus 3 times 0 minus 3 all over 0 minus 3 times 0 plus 2. And we get negative 3 times negative 3 all over negative 3 times 2. Oops, that's supposed to be positive. Oh, that's messy, messy. Messy, messy. 2. And we get 9 over negative 6, which actually simplifies to negative 3/2. So our y-intercept is 0, negative 3/2. Okie dokie. We have our x-intercept, we have our y-intercept. Now we're going to look at our vertical asymptotes. Our vertical asymptotes occur when the bottom equals 0. But no holes. That's why I brought it up in the beginning. It makes the whole thing janky. So we have to ignore that x minus 3, and we focus on the x plus 2. X plus 2 equals 0, that'll mean that x equals -2. So we have a vertical asymptote at x equals -2. And moving right along to horizontal asymptotes. Horizontal asymptotes use the low over high equals y, high over low equals no, same over same coefficients you name. And if you look at the original, all the way up here, you see that we have same over same. 2x squared divided by x squared, coefficients you name. Your coefficients of your highest power were 2 divided by 1 or 2. So your horizontal asymptote is y equals 2. Okay, we have our horizontal asymptote, we have our X-intercept, we have our Y-intercept, and then we have this thing called a hole. And our hole occurs where everything cancels. And everything cancels at x minus 3, which means that when x minus 3 equals 0, that's a bad, I skipped too many steps. X equals 3. So when we go to graph this, we're going to have a hole at 3, 0. We're going to have a vertical asymptote at x equals -2, a horizontal asymptote at y equals 2. And we have an X-intercept and a Y-intercept. And I'm going to graph this, lickety-splickety. Okay. I graphed my vertical asymptote, y equals, oh gosh, that's the wrong thing altogether. X equals -2. Our horizontal asymptote, y equals 2. Our X-intercept, our Y-intercept, and our hole. Our hole was at 3, 0. Okay, give me a second. And y'all, I am silly. I am so silly. I put these all in the wrong place. Let me undo. 61. There. Boop, 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 boop. I put the X-intercept in the Y-intercepts place and the Y-intercept in the X-intercepts place. I'm just trying to make sure you feel human. -3/2 and 3/2, and our graph looks like this with a hole at 0, with a hole at 3. When x is 3, let me see what y is. That's the problem. Okay, sorry. So in order to figure out where your hole is, you have to plug in that value back in to the part that canceled, and that's what I just did. Holes aren't very critical. The important part is that you get the asymptotes. Okay, phew. Sorry this was so long. It was only 2 examples. And hopefully this video has helped those of you who weren't able to attend on Thursday or Friday. Have a good day. Take care. Bye.